people say whatever it is, but I say it, you say. And this is plural of locus. Locus is singular and plural is loci. Now, what does locus mean? Locus basically, the English meaning is path. Okay, but here what do we say is locus is the path of a moving point. In maths we say path of a moving point. A point which is moving, satisfying certain conditions. Now what is it? You will come to know. Now suppose there is a point A and there is a point B. These are fixed points. These are not moving. A point P is moving. And how is it moving? It is moving in such a way that it is always equidistant from these two points A and B. That means suppose P is here, or say its first position P1 is here. So P1A is equal to P1B. Then we say it is equidistant, isn't it? Now suppose this point P1 moves to this position P2. Then also P2A, P2B will be same. Now suppose this point moves to this position P3. So it is moving in such a way that its distance from these two fixed points remains same. So then if you join P1, P2, P3, this becomes the locus of the point, moving point P. That is the path of the moving point. So instead of path we call it locus. Okay. So now so this path, it is found mathematically that it is the perpendicular bisector of the line joining AB. This happens to be the perpendicular bisector of the line joining the two points, fixed points A and B. So whenever you have to find the locus of a moving point which is moving how? Which is moving equidistant from two fixed points. It will be always the perpendicular bisector of the line joining the two fixed points. This is actually theorem 1. So this theorem will not be asked, nor you have to write the theorem. You have to only apply the theorem while first term. So whenever you have to find the locus of a point which is moving equidistant from two fixed points, then what you have to do is simply join the 2 points and draw the perpendicular bisector. And that will be the locus of that point. Okay? Now the second theorem says that if a point is moving in such a way that it is equidistant from two intersecting lines. Intersecting lines means suppose AB, CD. These are two intersecting lines. So they are intersecting, say, at this point O. Okay. So now this point is moving, P is moving in such a way that it is equidistant from both the intersecting lines. Means what? Suppose the point is, the first position of the point is P1. Okay. So now equidistant means what? If you drop a perpendicular, say PM, P1M, and here these two perpendiculars will be of same length, then this point is said to be equidistant from both the lines. Isn't it? Perpendicular distance is same. Now suppose this point P1 moves to here. So how it will move? It will move so that the perpendicular, so this is M1, N1. Again if you draw perpendiculars on both the lines, they will be equal in length. Okay? So like this, suppose it moves to now another point, position P3. Even then it will be equidistant from both the lines. So this will be same. Okay. So now if you join these various positions, this will be the locus of the point P. And what it turns out to be? It turns out to be the angle bisector of the angle between the two intersecting lines. Okay? So that means if you want to find the locus of a point which is moving equidistant from two intersecting lines, simply what you have to do is you have to draw the angle bisector in order to find the locus. These are the two theorems. So first theorem says the locus of a point moving equidistant from two fixed points is the perpendicular bisector of the line joining the two fixed points. And second theorem says the locus of a point moving equidistant from two intersecting lines is the angle bisector of the two lines. Got it? So now first we will do some warm-up sums, then we will go to the real sums which you get of your level. These questions are usually they carry 5 marks. Okay, so 5. Sometimes if a simple question is given, then 4. So usually these loci sums are combined with either the ogive which carries 6 marks, 6 plus 4, or histogram 5 marks plus this 5 marks, or it will be combined with those measures of central tendency 3 methods we did, they also carry 5 marks. So 5 and 5. So these questions are very scoring. So this geometrical construction is also very easy, and those tables you already know, those 3 methods of measures of. So usually that one particular question 10 marks is in your pocket. Measures of central tendency and this one locus. Or ogive is also you are very fine. You have finished ogive, isn't it? Your batch I finished. So ogive and this combined, that also becomes very easy. Okay, and it comes in section below. Okay, now first we are doing little warm-up sums. 1 or 2 we will do warm-up questions, then we will do. So write down the first question. Draw a line AB is equal to 6 centimeter. Write down the question also, otherwise you will not follow. Draw a line AB is equal to 6 centimeter. Draw the locus of all the points which are equidistant from A and B. So, do you follow what you have to do? You have to draw the perpendicular bisector of AB. Why? Because A and B are 2 fixed points and they want us to draw the locus of the points which are equidistant from A and B. So basically, according to first theorem, the locus of such points will be the perpendicular bisector of the line joining AB. So that's what I do. This is a warm-up question. Such a simple question will not be given to you, but for practice let us do. So AB is 6 centimeter. Draw AB straight line. I am taking in inches and double so that you can see clearly. So A, B. It should be very neat, no double lines, no double arcs. Okay? So you have drawn AB. Now you have to draw the perpendicular bisector. So take the compass. And put the pointer at A, and with radius equal to more than half of AB, approximately. More than half of AB, draw like this, 2 arcs on both sides of AB. Always you must draw the line at the center of the paper. Center of the paper. Okay? Then without changing the radius. Should not change the radius. Now with put the pointer at B and draw 2 more arcs cutting the previous ones. Okay? Now mark the point of intersection of both the arcs. Okay? And join them and produce both sides. Okay? And then say PQ. So PQ is the required locus.
When we are drawing the arc, what should be the measurements of the round?
That's not at all. More than half of the AB, line AB. More than half. Approximately. You need not measure. Just put it here and see more than half. And once you have fixed it, for the next arc, you should not change it. And that statement has to be written. PQ is the required locus. Angle has to be made only with compass and ruler. Protractor cannot be used.
And this is also walnut.
Yes. Still this can be asked for 4 marks. Find a point P which is equidistant from AB and BC, and also equidistant from A and B. So here AB and BC are 2 lines, okay, isn't it? And they are arms of the angle ABC. That means they are 2 intersecting lines. So P will lie on the angle bisector of angle ABC because it has to be equidistant from the 2 intersecting lines AB and BC. So in these diagram, in these things, if you draw a rough sketch, many times it becomes helpful. So A, B, C, this is 60 degrees. AB is given as 4.6 centimeter This rough sketch is not compulsory, but if you draw it will become easy for you. BC is 5 centimeter, angle ABC is 60 degrees. And now we have to find a point which is equidistant from AB and BC. So what we will draw? We will draw the angle bisector. You remember in smaller classes you have learned how to draw the angle bisector. And it is also equidistant from A and B. Means what? Points A and B. A and B are 2 points. So you have to draw the perpendicular bisector of AB. So suppose this is the perpendicular bisector of AB. So where these two meet, that will be the point P. Because P lies on the angle bisector, so P will be equidistant from AB and BC. P also lies on the perpendicular bisector of AB, so P also will be equidistant from A and B. That is what they have asked. So that is what we have to do. So now draw BC is equal to 5 centimeter.
How do we find the perpendicular bisector?
How you do that? Yeah.
Angle bisector P कैसे निकालेंगे?
Because P is the point of intersection
No.
of the angle bisector.
How will I find the angle bisector?
That's what you will draw an arc.
Yeah.
This arc will be already drawn for you while making 60 degrees. You will already have this arc. So from these 2 points, you will draw these 2 arcs, taking a convenient radius.
So what will be the radius?
Convenient radius. And it will take big radii, so the diagram will complete. Okay? So BC 5 centimeter you draw. Draw always in the center of the page. Now 60 degree angle, you remember, using a compass. So take some convenient radius and you have to draw the angle at B. So at B you will put the pointer and draw an arc, and with the same radius, without changing the radius, draw another arc. This is 60. You remember from here if you draw another arc, that will be 120. Right? So now this is somewhere A is here, but you cannot measure and mark. You have to draw an arc. The AB is how much? 4.6. So you will take the compass, put it on the ruler and measure it for 4.6. Okay? And then from here, from B, you draw an arc. So this will be your A. Followed? Yes. Don't measure it and simply write A there. You have to everyone see. This is A. Right? Then angle bisector.
Now for 60 degrees we have to take an arc smaller than the middle of both B and C.
No, nothing like that. Convenient radius. Any radius. Okay? Now already this arc is there. So from this point again now change the radius, increase the radius. So the diagram will look neat. From this point draw one arc without changing the radius, and from this point draw another arc. Okay? Got it? From here, say call it M, and this is say N. So from M and N, I have drawn these 2 arcs. So now point of intersection and B you will join. So this is the angle bisector. Now we have to draw the perpendicular bisector of AB. So now A is here. Usually children do the mistake of taking A somewhere here. A is here. So this is AB. And we have to draw the perpendicular bisector of AB. Got it? Following?
Yes.
Others are all following? Now, we have to draw the perpendicular bisector of AB. So we have to take radius more than half. So one on this side, one on this side, then with the same radius, one here, one the other side. Okay? Now these 2 points we will join and produce both sides.
Ma'am, can you show again how you made that line? Can you show again how did you make that line?
Which line?
Just from the
Perpendicular bisector. From here I drew one half this side and this side. And from A with the same radius, one half this side and one half this side. Cutting the previous one. So the point of intersection of both of these, angle bisector and perpendicular bisector, is P. So we will write P is the, you will write P here and then you will write P is the required point. Okay?